Okay, hello my dear students. Let us take one more example on I section, but we'll take this is an unsymmetrical I section. Okay, figure shows a rolled steel beam of an unsymmetrical I section. If the maximum bending stress in the beam section is not to exceed 40 MPa, find the moment which the beam can resist. Okay, here the stress is given, that is 40 MPa, and you have to calculate I. Okay, once if you get I, you can calculate Y maximum also. So only unknown, that is moment, so that can be calculated. So this is the given figure. It is unsymmetrical I section. You can see here on top this it is 100 into 50, and here this is area is 200 into 50. So what we will do, first let us calculate Y bar. How we can calculate Y bar? A1 Y1, here three sections are there. So A1 Y1 plus A2 Y2 plus A3 Y3 divided by A1 plus A2 plus A3. I'll take this as the section 1 and this is section 2 and this is section 3. So we'll calculate first A1 Y1. A1 is 100 into Y1, 100 area first, 100 into 50 into Y1. So I consider the neutral axis at the bottommost layer now. This is just an assumption. So Y is what? Distance from the center of gravity or CG to the neutral axis. Now our neutral axis is here at the bottommost layer. So distance from here to here. What is that distance from here to here? This is the center of the rectangle, that is 50. CG lies at a distance of 25 meter. So here to here, that is 25. 25 plus this distance 200 plus 50. So 200 plus 50, 250 plus 25, it becomes 275. Okay, next we'll go to the next section, that is this area is now 200. This area is 200 into this, that is 50, B into D, 50 into, now the CG is somewhere here. So distance from here to here, what is that? 200 divided by 2, that is 100. CG lies at a distance of 100 meter. Okay, so 100 plus 50, so that is 150. Third section is 200 into 50 into Y3 is this distance from here to here. Okay, so that is Y3 25. Okay, so divided by A1 100 into 50 plus A2 200 into 50 plus A3 200 into 50. So you get 125. That is from the bottom, because I have considered here from neutral axis at the bottommost layer. So whatever you get, that answer is YB. Okay, now we have to calculate what is Y from the top. So the total distance is 200 plus 50 plus 50, 300. 300 minus 125, that is 175. So I have marked here, this is Y T from the top, that is 175, and this is bottom, that is YB, that is 125. Okay, now you know the actual position of the neutral axis. So you can show that I have drawn here the position of the neutral axis, which is at a distance of 175 here, from here to here, from the topmost layer, and 125 from the bottommost layer. Now you can calculate I. How we can calculate I? How we used to calculate for T section? Same formula here we have to use, that is BD cube divided by 12 plus A into Y square. Okay, so I will take first I will consider I. So that is BD cube divided by 12. For the first section, BD cube is 100 into 50 cube divided by 12 plus area 100 into 50 into, now Y is distance from the CG to the neutral axis. Always you have to remember that Y is distance from CG to the neutral axis. CG is here, neutral axis here. So I want the distance from here here to here. I want the distance from here to here, that is y1. So what is that distance here? This is 25. So what you have, this is 175. So 175 minus 25. From here to here, this is 175. So 175 minus 25. If you deduct this, you get 25. 175 minus 25 square. Okay, that is y. Then for the next section, that is 50 into 200 cube divided by 12, that is this section. B is 50 and D is for this 200 cube divided by 12 plus ay square. A is 50 into 200 into y square. Now you have to again find what is y. See here, this is 50, right? And this is CG is located at a distance of 100 meter. So total this is 175 from here to here. So this CG is 100 and this is 150. So till here it becomes only 150. Correct? 50. Total it is 175, but our CG located 50 plus this is 150. So the location of CG is somewhere here, right? Because you have to think where you can write that CG, because the distance of CG is now at a distance of 100 meter here. This distance is 100 because total 200, CG lies at a distance of 100. So till here it is 175. So we can take CG lies over here. So now we want the distance from here to here, that is y2. So what is that? So how it total distance you know from here to here, that is 175 minus 50 minus this portion, that is 100, 200 by 200, you get this. I hope you understood. Total 175 minus 50 minus 100. So that is 175 minus 50 minus 100 square. Okay. So then third section, that is the last one, 200 BD cube, 200 into 50 cube divided by 12 plus ay square. A is 200 into 50. Y is distance from here. Now again y is distance from CG to the neutral axis. CG is somewhere here, that is at a distance of 25. So y is, this is your y now. So okay, I'll just write this is y1 and this is y2 and this is y3. Okay, so now I want the distance from here to this distance, neutral axis, distance from the CG to the neutral axis, that is total we know this is 125. 125 minus this, that is 25, you get 125 minus 25 is equal to 100. Okay, so I think all of you understood, because here this distance from here to here, total 125 minus this 25, you get this. So once if you simplify this, you get the answer 255.2 into 10 raised to 6 mm raised to 4. Now you can calculate what is section modulus. Section modulus is Z is equal to I divided by Y. Here what is Y? Since the value of Y is 175, that is greater of the two values between Y1 and Y2. See here what you have to take, Y maximum you have to consider. You have Y from the top it is 175 and from the bottom is 125. So Y maximum is 175. So you have to consider Y maximum is 175. Okay, simplify this, you get 1.46 into 10 raised to 6 millimeter cube. Now you can calculate what is moment of resistance. Moment of resistance is equal to sigma into sigma maximum into Z, that is sigma maximum is 40, it is given, into Z is 1.46 into 10 raised to 6, that is equal to 58.4 into 10 raised to 6 Newton millimeter or 58.4 kilonewton meter. So in this way you can calculate the I for the unsymmetrical section. I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.